Hey guys, so today we're going to be talking about the gradient intercept form, or better known as y equals mx plus b, as part of linear relationships. So let's get into it. So the aim for this video is for you to be able to rearrange any given equation of a straight line into the form of y equals mx plus b, and then be able to identify from that the gradient and the y-intercept. So let's get a bit into theory just to explain what we're talking about here. When an equation of a line is written in the form of y equals mx plus b, it is called the gradient intercept form. So sometimes we'll call it the gradient intercept form, but more commonly we'll just refer to it colloquially as y equals mx plus b. So what is y equals mx plus b? Well, we call y and x variables, or things that change. And we call m and b constants, or things that stay the same. As we do a few examples, this will make sense to you. So what is gradient and y-intercept and all those words I was using before? Well, let's go into just y equals mx plus b and say, okay, if we know that y and x are variables or things that change, well, m is a constant. And m in the gradient intercept form refers to the gradient or slope. Now we'll get into what gradient and slope is and how we calculate it in further videos, but for now, we just want to be able to identify that the m value refers to the gradient or slope, and the b value refers to the y-intercept. And we'll get into what the y-intercept is and how we calculate it and use it in other videos. Now, one thing to remember is that if the equation of the straight line is not in the form of y equals mx plus b, it is recommended to change it into this form by making y the subject. And you've seen in other videos how we change the subject of a formula. Now, all of this may sound like a bit of gibberish to you. Let's get into a few examples and all of this will start to make sense. So for the first example, it says, identify the gradient and the y-intercept of the following. And remember, previously we said, in order to identify the gradient and the y-intercept, I need to be able to rearrange the formula into the syntax or structure of y equals mx plus b, if it's not already in that form. Now looking at example 1, y equals mx plus b. It is already in the syntax or structure of y equals mx plus b. So I don't need to rearrange anything. But here I can very quickly identify the value of m, or gradient, and b, or y-intercept. So let's have a look at this. M is 2, and b is -6. Now m and b values can have negative values as well. They don't always have to be positive. So if m is 2, the gradient is 2. And if b is -6, well, the y-intercept is -6. Let's go on to a few more examples. So, example 2. 2y equals 10x plus 22. This is not in the form of y equals. This is 2y equals. So we need to convert this into y equals mx plus b. So how do we convert it into y? Well, right now it's 2 times y. The opposite of 2 times y is divided by. So the inverse of times 2 is divided by 2. And I have to divide everything by 2. Very important, you divide each individual element by 2 so that we can make it equivalent. So when we divide everything by 2, I get y equals 10x divided by 2 is 5x, and 22 divided by 2 is 11. So now I have it in the form of y equals mx plus b, where gradient is 5 and y-intercept is 11. Let's move on to a little bit of a harder example. Now in example 3, I have 6y plus 3x minus 10 equals 0. So my x and my b value is on the wrong side of the equals first, and y is not by itself. So I have to do a few things to get y by itself. The first thing is I'll take the the mx value across. Right now it's plus 3x. The opposite or inverse of plus 3x is minus 3x. So I'm going to minus 3x on both sides. And now I have the mx on this side. I still need to take the b value across. So that's minus 10. The inverse of minus 10 is plus 10. Plus 10 on both sides. Now I have the mx and the b value on that side, but y is not by itself. It's not y equals, it's 6y equals. So just like in example 2, now the inverse of 6 times y is divided by 6. So I divide each element by 6. And I'll get y equals minus 3 divided by 6 is negative a half, or negative 0.5, and 10 divided by 6 is 5 over 3. We leave them as fractions unless they are terminating or decimals or integers. So they decimals that stop or they're whole numbers. So here I can leave that as negative a half, or I can say that m is negative 0.5. They're both correct. And the y-intercept is 5 over 3. And I'll leave that as 5 over 3 because that is not a terminating decimal. Let's move on to example 4. Now example 4 says that x over 2 equals 2y over 3 minus 10 over 11. So I have two fractions on this side, and I need to simplify those fractions first. So how am I going to do that? Well, very simply, when I'm adding or subtracting fractions, the denominator has to be the same. If the denominator is not the same, we use the butterfly method, where I get the 3, the denominator of the first fraction, and multiply top and bottom of the second. And I get the denominator of the second fraction and multiply top and bottom of the first fraction. So when I do all of that, I get 22y minus 30 all over 33. And now, just like we have in previous videos with equations, when I have a fraction equals another fraction, I can cross multiply to simplify this. So I do 33 times x and then 2 times everything on that side. So 2 times 22y and 2 times negative 30. I get this structure, the blue there. Now, just like I did in example 3 and example 2, I need to rearrange that to make y equals mx plus b. And you'll see I've done a number of steps there. The first thing I did is I took the b value across to get y by itself. When I did that, I still have 44 times y. Y is not by itself on that side of the equals. So, just like we did in example 2, 44 times y, the inverse is divided by 44. And each element has to be divided by 44. When I do that, some of them turn into terminating decimals and some of them don't. So I leave them in their most appropriate, accurate form. So therefore, y equals 0.75x, or I can leave that as a fraction, plus 15 over 11. So my gradient is 0.75, and my y-intercept is 15 over 11. Make sure you pause this and write down the examples with your own steps and own notes next to it as you go through it. Let's go on to example 5. Now in example 5, I have all decimals, but that doesn't make a difference. The steps and procedures will still remain the same. So I need to get y by itself. So the first thing I do is I take the mx value across. And once I've done that, it's still 1.3 times y, just like we have in the other examples. I need to get y by itself, so I'm going to divide every element by 1.3, and I end up with a fraction and a whole number. So my gradient is negative 5 over 13, and my y-intercept is 5. We just want to identify the gradient and y-intercept at this stage. Later on, we'll learn how we can calculate them, what they tell us, and why they're important. Make sure you're writing all these down with steps and clear notes next to them as you pause the video. Now I have a few questions here that I'd like you to try yourself, Here, you need to identify the gradient and y-intercept just like we did in all the examples above. Pause the video, try them yourself, and then unpause the video to come and go through the recommended answers. Well, there you have my recommended answers. Hopefully, you learned today how to rearrange and make an equation of a straight line in the structure of y equals mx plus b, and also identify what the gradient and y-intercept of that line would be. If you got any wrong, go back through the video and watch it again. Till next time, take care, guys.